All right, guys, looking at pyramid here, and what I want to do is this is actually the formula for the surface area of a right rectangular pyramid. It's a big, long formula, but what I want to do is show you where these different components come from. So here's what we're going to do. We're going to highlight first the two different bases, or I'm sorry, faces, not bases, the two different faces that are going to be congruent here. So in red, I've highlighted the two different faces of this pyramid that are going to be congruent. So what we want to look at is how does this particular thing break down? So we've got those two faces. We've also got these two kind of on the left and right, if you want to think of it that way. The faces of a pyramid are always going to be a triangle. So back here, here's my other triangle. So in green, we'll try to color code this so you can keep things straight. So first thing I want to look at in this formula is L times W. That's the first component. Well, L times W is just this length times this width, and that's the area of the base. And in a pyramid, we only have one base. So what we want to do is just find the area of that thing. If it's rectangular, then we take the area of a rectangle, which is length times width. All right, the next thing we want to look at are these red triangles here. So these red triangles, kind of the one in the front and the back, if you want to think of it that way. So in thinking about these two triangles, they are going to be congruent. These two triangles are. So what we want to do is look at the different pieces. Well, in that triangle, L represents the base of that particular triangle, that red triangle. So that's where that comes from. Okay, so we're going to add in the second piece, and L is the base. So that is the base of this thing. The next piece is this big, long square root piece. And where that comes from, guys, is if we take just looking at this particular triangle and we draw an altitude of that face. So we drop that line down from the vertex up top to the base of this triangle that is a face of a pyramid. What we've created essentially is a right triangle on the face, but you've also created a right triangle with the height of the pyramid. So H is the height of the pyramid, and what we're investigating right now is this triangle that kind of looks like this. Here's the middle of the pyramid, right here. So that's the height of the pyramid. This is the height of the face that we're talking about. All right, so we're going to call this A1. So that's the height of the face, A1. And this distance right here, if you can see on our diagram, this entire distance is W. Well, this is half the pyramid, so this is going to be W over 2. And so when we take a closer look at this, we can figure out what A1 is by using Pythagorean theorem because we've just created a right triangle. So we know that A1 squared is going to be equal to H squared plus W over 2 squared. And maybe I'll try to write it in the same terms that they use here. So they wrote it using W over 2 squared first. So that's where this comes from. W over 2 is the base of this triangle, which we've created. That thing squared plus H squared. That's where that this thing comes from. So if we want to solve for what we call the slant height, if we want to solve for the slant height, we're going to take the square root, and that is that expression. So we get the square root of W over 2 squared plus the height of the pyramid squared. All right, so that's where this piece comes from. So writing this in different terms, we've got the base plus L, remember, is the length right here, times the slant height, which we called A1. So this is the slant height of the one face. All right, the last little piece of this, because we're dealing with a triangle, remember that the area of a triangle is equal to 1/2 the base times the height. And when we're talking about this red triangle right here, L is the base, H is the height. We know we have two of these triangles, or two of these faces that we need to account for. But in order to find the area, we've got 1/2 the base times the height of this one. And we have two of those. So what it becomes is 2 times 1/2, and that just drops off. So area of, so this is actually the expression for the area of this red, I'm sorry, both of these faces in the front and the back, if you want to think about it that way. All right, second part is very similar. What we're going to do is create this kind of inner triangle, if you want to think of it that way. I'm going to connect that and create this right triangle. And this piece right here would just be the height of that triangle, the height of that face. And so we've created something that looks like this. And where this is now the slant height of these other two opposite faces, the left and the right, if you want to think of it that way. And this piece right here is the height of the pyramid. This guy down here is not W over 2, but we're going this way. So it's now length. It's now half the length. So this would be length over 2. So again, we can go through a similar process, use Pythagorean theorem, but that's where this piece right here comes from. So writing this in terms of the slant height of these particular faces, A1 is going to be the slant height of the front and the back. A2 is going to be the slant height of the right and the left. So the point here, guys, just to kind of sum some things up, is that we have a formula for the surface area in terms of slant height, which is down here. But we also have a formula in terms of the height of the pyramid. And we can use that, and we can just plug these in according to which is most appropriate.